Hello students, I am Lakshman Singh Rawat, PGT Chemistry at CIS Dasua. Students, I hope you are enjoying this method of teaching learning that CIS Dasua has come up in this hours of crisis. CIS Dasua's e-learning is helping students to study at their home so that they do not lag behind due to this lockdown. Students, I hope you have seen the previous lectures. Now today also we'll continue with some basic concept of chemistry. In today's topic, we'll be discussing the percentage composition, and then we will be using the percentage composition to find out the empirical and molecular formula. Before we start with today's topic, let us quickly recap what we had done in our previous lecture. After that, we will use those concepts to solve the numericals. The solving of numerical based on mole concept become very easy if we can understand this cycle. Here, you will notice that the mole is at the center, whereas the gram molar volume, gram atomic mass, the Avogadro number, and the gram molar mass, they are at the corners or periphery. If you have been given any one of the quantity, you can easily convert it into another quantity using this cycle. From anywhere you start, you will have to go to mole, and from mole you can get the another quantity. For example, let us suppose you have been given mass of a substance. Let's say we have been given a compound and its mass is given. So first of all, we will have to, and you have been asked to find out the, let's say, number of the molecules in that given mass of compound. Then what you will do, you will find out the relationship between the mass and mole, and from mole to the Avogadro number or number. Okay, so later on we will understand that you can directly use the relations also. Basically, what do you want? You want a relationship between the gram molar mass and the number. So you can correlate the gram molar mass with Avogadro number, but that you can do later on once you have understood the concept. So first of all, convert it into mole, and from mole go to the Avogadro number. So what you will do is, from the given mass, first find out the number of moles. And once you get the number of mole in the given mass of substance, then you can convert it into the Avogadro number. Simply by multiplying the number of mole with Avogadro number, you get the number of particles. Okay. Let us start the day with discussion of the topic percentage composition. Now, why do we require this percentage composition? At time we are given the percentage composition of different element, and we use this percentage composition of these different element to find out the formula of the given compound. Okay. Also, we may use this percentage composition to find out the purity of a sample, and this is found out by mass percentage of an element is equal to mass of that element to the molar mass. Now let us take example of water to find out the percentage composition. Since we know that the formula of percentage composition is mass percent of any element is equal to mass of that element divided by the molar mass of compound into 100. Okay, that will give you the percentage mass of any element. So the molar mass of water is 18.02 gram, and therefore the mass percentage of hydrogen is mass of hydrogen. There are two atoms, so 2 into 1.008 upon molar mass of the compound, that is 18.02 into 100. That will convert it into percentage term. So that works out to 11.08. 0.18% of hydrogen is present in water, and the mass percentage of oxygen is the mass of oxygen upon the molar mass of the water into 100. So 16 upon 18.02 into 100 will give you 88.79%. So the mass percentage of hydrogen is 11.18 and the mass percentage of oxygen is 88.79% in water molecules. Now let us see another example where we have to find out the mass percentage of different element in the case of ethanol. Since we know the formula that mass percentage of element is given by mass of that element upon molar mass of the compound into 100. Molar mass of ethanol is sum of the atomic mass and we get it equal to 46.068 gram. Now mass percentage of carbon equal to the mass of carbon upon the molar mass of ethanol into 100. Mass of carbon is 2 into 12.01, that works out to 24.02 upon molar mass of ethanol, that's 46.068 into 100. The mass percentage becomes equal to 52.14%. Then mass percentage of hydrogen is 6 into 1.008 upon the molar mass of ethanol into 100, and that becomes equal to 13.13%. And similarly the mass percentage of oxygen comes out to be equal to 34.73%. Now in the case of ethanol we have seen that the mass percentage of carbon is 52.14, mass percentage of hydrogen is 13.13, and mass percentage of oxygen is 34.73. With the help of this mass percentage we will try to see what we can find out. Now let us try to understand the empirical and molecular formula. After that we have understood what is the mass percentage of an element. In fact, the mass percentage of an element can be used to find out the empirical and molecular formula. First, let us discuss what is empirical formula. In fact, empirical formula represents the simple whole number ratio of the various atoms present in an element. An example has been taken here, that of glucose, C6H12O6. This is the molecular formula and the empirical formula is CH2O. That means when we divide the actual number of molecules by the HCF, we get the simple whole number ratio between all these elements which are present in the given molecule. So for glucose C6H12O6, the empirical formula is CH2O, which shows the simple whole number ratio of different elements. Now what is molecular formula? In fact, molecular formula shows the exact number or the actual number of different type of atoms present in a molecule of a compound. Here we have taken example of ethanol, C2H5OH, which is the molecular formula, and the empirical formula of this one is C2H5OH. In this case, the empirical formula as well as the molecular formula remain same since they cannot be simplified into a simpler ratio. So in this case, the molecular formula and the empirical formula both will be same only. Now let us see how we can find out the empirical and the molecular formula. If we know the mass percentage of different element present in a given compound, then we can easily find out its empirical formula. Further, if we know the molar mass of the compound, then we can find out the exact molecular formula also. The relationship between the molecular formula and the empirical formula is molecular formula is equal to n time of the empirical formula, because the empirical formula is the simple whole number ratio of the different element present in a given compound. So if we multiply it by n, we get the molecular formula, which gives the actual number of the different atoms present in a given molecule, where n can take up the value 1, 2, 3, 4, anything. And how do we find out this n? N is equal to the molecular formula mass, that is the molecular mass of the given substance divided by the empirical formula mass. This will give us the value of N, and from the value of N we can easily find out the molecular formula by multiplying the empirical formula with N. Now let us use the percentage composition to find out the empirical and molecular formula. We have got a question here. A compound contains 4.07% hydrogen, 24.27% carbon and 71.6% chlorine. The molar mass is 98.96 gram of this compound. Now we have been asked to find out the empirical and molecular formula. Let us solve it. First of all, we write the elements in sequence, carbon, hydrogen and chlorine, and write their percentage in front of it. Carbon is 24.27%, hydrogen is 4.07%, chlorine is 71.65%. Since the masses are given in term of percentage, it can be directly converted into grams, considering that the total mass is 100 gram. So carbon becomes 24.27 gram, hydrogen becomes 4.07 gram and chlorine is 71.65 gram. Convert each one of them into moles. That is done by dividing the mass by the molar mass. Okay, so this is the given mass, 24.27 is the given mass. Dividing it by 12, that is the molar mass, will give you the number of moles of carbon, and it is equal to 2.0225. Similarly, for hydrogen, dividing the mass by molar mass will give you the number of mole as 4.07, and in the case of chlorine, dividing the mass by molar mass gives the number of mole as 2.018. Now this has to be converted into the simple ratios. What is the ratio between all these elements which are present in the given compound? So what we do is we divide by the smallest number here. Okay, smallest mole value, we divide by smallest mole value to get the ratios between these different elements. So dividing all of these moles by the smallest value, that is 2.018, we find that for carbon it is almost equivalent to 1. In the case of hydrogen it is equivalent to 2, and in the case of chlorine it is equal to 1. So the ratio of carbon, hydrogen and chlorine is 1:2:1, and this will give us the empirical formula. Now that we have obtained the ratio of different element present in the compound, we can write the empirical formula as C ratio H ratio Cl as C1H2Cl1. This will be the empirical formula. Now we have to find out the molecular formula. For that we will require the empirical formula mass, and the empirical formula is CH2Cl. So the empirical formula mass becomes 12 plus 1 into 2 plus 35.5, okay, equals to 49.5. Here 12 was the atomic mass of carbon in the empirical formula, plus 1 is the atomic mass of hydrogen, into 2, that is the number of hydrogen in the empirical formula, plus 35.5, that is the atomic mass of chlorine, and the empirical formula mass becomes equals to 49.5. Since the molar mass is given, to find out the value of N, what we will do is the molar mass will be divided by the empirical formula mass. The molar mass is 98.96 and it is divided by the empirical formula mass, that is 49.48. So dividing it, we get N equals to 2. So to obtain the molecular formula, we multiply the empirical formula by N. So empirical formula is equal to CH2Cl. All these terms will be multiplied by N. Hence, the molecular formula becomes C2H4Cl2. Okay, 2 chlorine, 2 to the 4, 4 hydrogen, and 2 1 2, 2 chlorine. That is the molecular formula of the given compound. Today we discussed the percentage composition, and then we discussed the empirical and molecular formula, and then solved numerical based on this concept. You can try a few more examples at your home. Till we meet next, study properly and have a nice day. Thank you.